Good morning, everyone. Today I will be discussing the journal club topic in the name of Synthesis and Characterization of Dental Nanocomposite Resins Reinforced with Dual Organo-Modified Silica Clay Nanofiller Systems. This journal this article was published in the Journal of Functional Biomaterials in the year 2023 with an impact factor of 5.2. I want to discuss some terminologies related to this journal club that will be helpful for knowing the article better. The first one is degree of conversion. It is the percentage of carbon double bonds in the resin nanomers that get converted into single bonds during polymerization. Why it matters? A higher DC means the composite resin is better cured, stronger, and less likely to release unreacted chemicals into the mouth. Polymerization shrinkage, the reduction in the volume that happens when resin monomers join together, polymerize, and form a solid network. Why it matters? Shrinkage can create gaps between the filling and the tooth, leading to micro leakage, sensitivity, or secondary caries. Quaternary ammonium compounds, it is the positively charged nitrogen based molecules that can be bonded to fillers or polymers to give them antibacterial properties. Why it matters? When integrated into the dental composites, quaternary ammonium compounds prevent bacterial growth without leaching out of the resin. Organo-modified nanoclays, nanometer sized clay particles that have been chemically modified with organic molecules to improve compatibility with polymers. Why it matters? They enhance mechanical properties, strength and stiffness, and may provide antibacterial functions in dental nanocomposites. Auto-acceleration gel effect, a phenomenon during resin polymerization where the reaction suddenly speeds up because the growing polymer chains restrict radical movement. Why it matters? It influences curing behavior, strength, and durability of the final dental nanocomposite. Talking about the materials and methodologies used, the resin based matrix was a base of BIS GMA, TEC DMA. 50 is to 50 by weight percentage was used. Camphor Queen 0.2% by weight and DMA EMA 0.8% by weight served as photo initiator system in the matrix. Nanofillers incorporated were organo-modified silica and 3 quaternary ammonium modified clays were used. First one was nanomer 1.34 mn, second was MMT CTAC, and third was SMMT CTAC. Composites were prepared with varying ratios, silica clay loading up to 60% by weight percentage. Preparation of nanocomposites, fillers were manually mixed into the resin matrix until fully weighted, then ultrasonicated for 10 minutes. 7 groups of experimental nanocomposites were formulated. Characterization techniques, SEM and X-ray diffraction for morphology and structure, polymerization and shrinkage kinetics by FTIR and LVDT, that is linear variable displacement transducer, mechanical properties by 3-point bending tests such as flexural strength and modulus, physicochemical test, water sorption and solubility according to the ISO 4049 standards. Coming to the results, morphological characterizations and XRD, SEM showed good dispersion of silica at 60% weight and mixed silica clusters at high clay loadings. XRD confirmed intercalation of polymer chains within clay layers, especially at 5 to 10% weight clay. At higher loadings, 20 to 30% by weight, stronger clay reflections suggested agglomeration. Polymerization kinetics, degree of conversion. The auto acceleration gel effect was observed with a steep rise in conversion at 20 to 25 minutes. The best degree of conversion was recorded for the various types of filler materials which were close to silica composites. Higher clay loadings reduced DC to 37 to 38%. When it comes about polymerization shrinkage, low shrinkage was observed in the groups, followed by the group that had 2.76% of the nanomer. Highest shrinkage was seen in SMPS nanomer and least in SMPS CTAC. Water sorption and solubility, all composites compiled with ISO 4049 requirements. Sorption increased with higher clay content. Lowest solubility was there in SMPS CTAC group and highest was in SMPS nanomer 30 by 30 group. Mechanical properties, flexular modulus, controlled silica resin had flexular modulus of 2.61 GPa. Higher clay loadings reduced modulus to 2 GPa. Flexural strength highest for SMPS nanomer compared to control. Lowest strength observed with SMPS SCTAC 50 by 10. The statistical analysis used was Shapiro-Wilk test, used to check whether the data followed a normal distribution. One-way ANOMA applied to compare flexular modulus, sorption, solubility, and polymerization shrinkage between the 7 experimental groups. Kruskal-Wallis test applied to compare flexural strength between groups. Bonferroni correction used to adjust for multiple comparisons and avoid false positives. Parameters compared were flexural modulus, flexural strength, polymerization shrinkage, water sorption capacity, and solubility. Type of study design, this was a laboratory based experimental study. Researchers synthesized 7 groups of dental nanocomposite resins with varying silica clay nanoparticle loadings and performed in vitro physicochemical and mechanical testing according to the standard protocols. Comparative analysis of different material formulations, cross-sectional lab investigation, not clinical, not animal study. Guidelines followed. It follows points explicitly referring to the ISO 4049 dentistry polymer based restorative materials, which sets minimum requirements for testing dental material composites. Checklist parameters which were fulfilled were material polymerization, preparation, and characterization, polymerization shrinkage measured using bonded disc technique, degree of conversion evaluated by FTR spectroscopy, water sorption and solubility conducted according to ISO 4049 limits, mechanical testing such as flexural and modulus strength performed with a 3-point bending test, statistical analysis used ANOVA and non-parametric test applied. Checklist parameters not fulfilled were randomization and blinding of samples, sample size justification, biological validation for antimicrobial testing or cytotoxicity studies were not done. Clinical translation in vitro findings only, no preclinical or clinical data to support immediate applicability. Long-term aging and cycling, only short-term water storage was used, no thermal cycling, fatigue testing or long-term degradation studies conducted. Coming to the strengths, novelty of the material design, comprehensive characterization was done, standardized testing protocols were used, balanced experimental design was used, clinical relevance on there, transparent discussion of limitations was there. Coming to the limitations of the study, sample preparation techniques by manual hand spatulation and ultrasonication. SEM revealed agglomeration of nanoclays at higher loadings which could affect reproducibility. No biological evaluation. Short term testing only for 7 days. No long term aging, thermocycling, or fatigue testing was done. Limited scope of mechanical testing was used. Only flexural strength and modulus were measured. Hardness, wear resistance, fracture roughness were not evaluated. No randomization or blinding was done. Small sample per group. Lack of clinical or in vivo validation. Future scope. The next step should focus on the biological validation, long term stimulation, advanced testing, and clinical translation. If successful, these nanocomposites could pave the way for next generation restorative materials that combine durability, aesthetics, and antibacterial protection. Thank you so much.